Alright, in this video we're going to be talking about the states of matter and also how those states behave, basically. And so we're going to talk a little bit about kinetic theory here. And in class you should have all these already written down. But basically kinetic theory tells us these four things: that all matter is composed of tiny particles, those particles are in constant random motion, and those particles will collide with each other, and also any walls of the containers that they're held. And then the amount of energy that the particles lose from these collisions is negligible. So negligible meaning it's such a small amount of energy lost that we don't even need to take it into consideration. So basically this overall thing just tells us that all matter, solids, liquids, gases, they have these tiny particles that are constantly moving. Even in a solid, they're still moving around. So, and they don't lose that much energy. So that's basically what kinetic theory is telling us. And in class, I think we talked about what you thought about whenever you hear kinetic. Usually you guys are probably used to hearing kinetic energy, and you can kind of think of it that way because kinetic energy is energy in motion. So just think of these particles that make up matter are always in motion. Okay, so gases. We talked about gas, liquid, and solids because those are the ones that we're most familiar with here on Earth. We did talk a little bit about what the most abundant state, or what state of matter is most abundant in the universe, and that would be plasma. That's because our suns and the stars are made up of plasma, so they make up most of the matter in our universe. If we look at gases, we talked a little bit about some of the traits and some of the behaviors of gases. Those two traits that we talked about were volume and shape, and whether they have a definite volume or a definite shape. In gases case, it does not have a fixed volume, and it doesn't have a fixed shape. So the shape of a gas, it just is going to take whatever shape that container is. So it could be this the air tank here, it could be the room that you're in, whatever that container is, that gas is going to expand to fill that whole container and take that shape. Now we talked about volume a little bit. You can see the volume, how much space is taken up by all these balloons that were aired up by this one container here. And so does gas have a fixed volume? That would be no, it does not have a fixed volume. That's because those particles are going to spread out to fill whatever container it is in at the time. A liquid. Liquids do not have definite shape, but they do have a definite volume. And so if we looked at, like I showed you guys in class, if we looked at the water inside this container, the shape is going to take whatever shape the container it's in. So if I pour it into another container, it's going to take that shape, but the volume stays the same. However much water was in the first container is going to be in the second container. And so we can kind of look around at some of these pictures I have up here, and you can look at the one for gas. You can see those particles are just going to kind of slide. They can slide past each other and move around a little bit. So they're going to have a little bit of energy, but not as much as gas does. And again, it has no definite shape, and but it does have a definite volume. If we look at solids, solids have both a definite shape and a definite volume. We also looked at whenever we add energy to it in the form of thermal energy. So if we add heat to something, this is what this video here shows. But basically it has a definite shape. So if we look at a solid object, obviously it's going to have a solid or a definite shape. I had some people ask me about silly putty, things like that. If you look at it at that point, it does have a definite shape. Now you can always manipulate these things and change their shape, but at that precise moment it does have a definite shape, and it also has a definite volume. This volume is not going to change unless you were to manipulate it. So you can cut that in half, then it might change the volume, but we're talking about this block at this moment. So if we added energy to something, so I gave you guys an example in class. We looked at the ring and the ball. The ball does not fit through the ring. what happens in general whenever we add energy to something? Those particles are going to start moving faster, and they're going to expand. They're going to spread out a little bit. So that is even true with solids. So we could take this ring here, add some thermal energy to it, heat it up, and those particles on the inside, even though they don't move a lot, they are going to expand some. And so if we heat it up enough, we can expand it enough to where the ball will actually fit through the ring. So you can kind of imagine these particles up here. They're still staying in place, but they're sitting there vibrating. They're still in constant motion the entire time. Yeah, so we got the ring to actually, or the ball to fit through the ring at this point. So temperature. What is temperature? Basically, whenever we're measuring temperature, you never really thought about what you're actually measuring. You're measuring the average kinetic energy of the particles in that substance. So let's go back this way. Wrong way. So in other words, if we increase the temperature, we have an increase in thermal energy. That in turn is going to make particles move faster, and then we have thermal expansion. So in most cases, if we add energy to it, we add heat to it, those things are going to expand. I did give you an example of water. So if we take away some of that heat, usually things are going to contract. But in the case of water, whenever we take away some of that energy and it forms ice actually expands instead of contracts. So why is that? That's because it forms a certain structure, and I'll show you an example of that here in a second. But it'll actually spread out a little bit, so that's why you have to, let me show you right now actually. So let's go to this little thing right here. So this is kind of a cool demonstration here. We can look over here, we have solid, so this would be a solid. These are neon molecules. That's what a solid, the particles inside of a solid would look like. If we change that to a liquid, they're going to kind of flow through each other. They can kind of move around a little bit, but they're going to stay relatively close. A gas would look something like this. If we started with a solid, we added some thermal energy, you're going to have thermal expansion. Those particles are going to start gaining energy. They're going to start spreading out more until they eventually turn into a gas. So they went from a solid to a liquid to a gas. Now if we look at water as a solid is a little bit different. You can see it has a certain structure to it. And so you can see how they kind of link together. And then there's these holes here with that's going to allow actual air pockets to go in there. So that's why ice actually floats in water, because they are going to actually be less dense at that point. Because they have a certain structure, a crystalline structure, they're going to expand a little bit. So we'll kind of look at water as liquid and then as water vapor. So you can kind of change the temperature there. You can see the temperature goes up as it turns to a liquid, temperature's down, solid, down even further. Okay, so you guys don't have any questions along with this video, just make sure that you take notes and do the video summary. See you in the class.